So here are the sums that I would like you all to learn and sum. The first question is example 1. In example 1, you have a circular motion in which the body goes from A to B. The body goes from A to B. It means it's covered 1/4 of the entire perimeter. They'll ask you the difference between distance and displacement. A displacement is just a change in the position, whereas the distance is the arc length, total length itself. So when they ask you displacement, it is just a change in the position. A displacement is just a change in the position, and so you can say this is r, the hypotenuse will be root of r square plus r square, the root of 2r square or root 2r meters, and that will be the distance, and that will be the displacement. And supposing they ask you distance is arc length itself, and it's 1/4 of 2 pi r, the entire perimeter of the circle. So it's pi r by 2 meters will be the distance that you should understand. So this is another part of the question where the same sum, they're saying the point A, from the point A, the body is coming from A to B. Then the displacement will be r plus r. So the displacement in that case, the second case, is just change in position, which is 2r. Whereas the distance, if you consider, it will be 2 pi r by 2, which will become r pi r. Arc length, the total distance is total length traveled, while displacement is just a change in the position. What happens when the body is going to start from A and come back to A itself? Okay, supposing the body is going to start from A, is going to come back to A itself, the net displacement will be 0. In that case, the displacement itself will be 0, whereas the distance that they ask will be 2 pi r. So clearly you should understand the difference between displacement and distance. Okay, so then that completes the first example. Next, let's go to example 2. So in example 2, a car is moving along the x-axis. Okay, as shown, it moves from O to P. So from O it starts and moves to P, and you can see that this position is at 360 is the meters. They've given till 400 meter. Okay, and 360 is the meter here, and the time is 18 seconds. The timings have been split into 2, 4, 6, 8, 10, 12, 14, 16, and then 18. And the distance is 40, 80, 120, 160, and so on. And comes to 200, 240, 280, and 320, and then 360. The body goes from O to P, and then it goes to Q, and where is Q is at 12. So the body goes from O to P, and then from P it returns back to Q. So in that case, the displacement will be just from 0 to 240. Can you see the corresponding distance? The position here is 240. Change in position is just 240. So if we are going to talk about the displacement will just be 240. The change in the position when compared to initial and final position is what is called displacement, and that's a displacement. And in that case, they ask you average velocity. Average velocity, displacement is a vector, velocity is also a vector, which is net displacement by time. The time taken for it will be total time, which you have to take it to 18 plus this distance, which is this time, which is 2 plus 2, 4, 4 plus 2, 6, 18 plus 6. 18 plus 6 is the total time taken. So then that's 360. If that's 240 is the displacement by 24 seconds, which will make it 10 meter per second, will be the average velocity. You understood what is the displacement, just change in position. So the final position is only here. So then initial is here, the final is here, and so change in position is just 240 divided by the total time taken. Supposing they ask you distance, this is object is starting from P and reaching starting from O and reaching Q. After going to P, coming back to Q. What is the distance? The distance will be the total OP distance plus PQ distance. An OP distance is 360 plus a PQ distance is, can you see, a 40 plus 40 plus 40. So can I say it's 120? Can I add a 120 to it? Which will make it 480 by the total time. So this is the distance, 480. And they ask you average speed. Average speed, in that case, it's just the total distance, which is 480 by total time taken, which is again 18 plus 24. 18 plus 6, which is 24. And So you can just calculate this. This will be 20 meter per second. So that's about this. And let's go to the next question. In the same subdivision, they're also asking you what happens if object is going from O to P, completely O to P, even the distance itself is 360. But the distance and the displacement will just be the same. And the object is moving in a straight line. When it goes from O to P, the distance is also OP, the displacement is also OP. In that case, it will be just 360 divided by the time taken for it to go from O to P. It's just 18 seconds. 360 by 18 will give you average speed or average velocity. Both of them will just be the same. Whether you take average velocity or average speed, that both of them will be the same. Thus, you'll get only an answer to be 2 meter per second. I hope you're clear with this question. So let's go to third example. The third example sum, where a body travels from A to B with the speed of 40 meter per second. And then it travels from B to A with a speed of 15 meter per second. Whenever they give you the distance of the same, immediately calculate the time t1 is equal to distance. Let's keep the distance to be d by 40, distance by velocity. And the time is here distance by velocity. So you know t1 and t2, the total time taken for it to go and come back is t1 plus t2, which is d by 40 plus d by 60. And they ask you the average speed. The average speed is a scalar, which is total distance, which is this d plus d will be 2d is the total distance for it to go from A to B and come back to B to A. By the total time taken is d by 40 plus d by 60. You take d out, common from the denominator, d and d get cancelled. 2 by 1 by 40 plus 1 by 60. Do the calculation and finish the sum. And so that's about this. You might end up getting a 48 meter per second to be the answer. You can verify your answer. That's about average speed. Supposing they ask you average velocity. Average velocity is not the total distance. Here the speed is total distance by total time taken. Whereas average velocity is total displacement. The displacement when goes to A and back to A, comes back, the displacement will be 0 by the total time taken. So 0 by any number is always 0, and so the average velocity in this sum is 0 meter per second. So let's go to fourth question. The fourth question, on a 60-meter track, the total distance is 60 meters. A train travels 30 kilometers for the 30 first half the kilometer in a speed of 30 kilometer per hour. How fast must a train travel x kilometer per hour? I don't know. How fast should it travel to cover the rest of the so that average speed, speed average speed is total distance by total time taken. Total distance by total time taken, and the total distance, you know that 60 kilometers is total speed, total distance. By the total time taken, you should calculate the time for this. Time is distance by speed. 30 by 30 is just 1. Let's calculate, this is t1. Let's calculate time t2 is distance, which is again 30 by the speed. Assume speed is x, so 30 by x. So the total time is 1 plus 30 by x. The average speed itself is given to be 40 in the question. So 40 is equal to, you have 40 distance, which is 60 by 1 plus 30 by x. So just cross multiply, you're supposed to get x. So let's do it. This and this get cancelled. This is 2 and this is 3. And cross multiplying, you get 2 plus 60 by x is equal to 3. 60 by x is equal to 1. So x is equal to 60 kilometer per hour. So that's your speed at which the second part of the journey should be covered. So let's go to fifth question. A body covers 1/3 of its journey. 1/3 means there are 3 parts of the journey. This is d, the total distance, d by 3, d by 3, and d by 3 is the distance in each part. A body covers 1/3 of a journey with velocity u. Okay, the next 1/3 of the journey with the velocity v. The last 1/3 of the with velocity w. Calculate the average speed of the body during the entire journey. As I told you, just keep calculating the time for it. Time is distance by speed. The time for this is t1, this is t2. Time for this is distance, okay, d by 3 by velocity, and time for this is distance by velocity. Thus, you get a total time t1 plus t2 plus t3 is d by 3u plus d by 3v plus 3d by 3w is the total time taken. And they ask you average speed, speed average average is total distance by the total time taken is d by 3u plus d by 3v plus d by 3w, where d, when you take a common in the denominator, d and d get cancelled. 1 by 3u plus 1 by 3v plus 1 by 3w. You take LCM here, you get answer. You'll get a 3uvw to the LCM. You have a u here, so you multiply this with a v and a w. This has got a v, so you multiply with u and a w. This got w, so you multiply with u and a v. And this goes up and the transfer is 3uvw by a uw plus u vw plus uw plus uv, whatever, and so that we get this answer in the textbook. So let's go to example 6. A body is traveling along a straight line. See, one half the distance with velocity v naught. So supposing this distance is d, this is d by 2 with velocity v naught. The rest of the journey they are covering with velocity v1 and v2 an equal time period. So let's assume this time period is t1, this is time period t2, this is time period t3, or let's assume the whole time period is t2. So exactly half the time period. So t2 by 2, v1 into t2 by 2 is the some distance, v2 into t2 by 2 is another distance, and you know the total distance itself for this is v into t2 by 2, v1 into t2 by 2, v2 into t2 by 2. That's the total distance considering v1 and v2 are the velocity. Velocity into time gives you distance. Time is considering the entire half the journey is t2, v2 by 2, t2 by 2. So from this you can see that you can take out t2 by 2 to be common. You have a v1 plus v2, which itself is this distance is d by 2. 2 and 2 get cancelled, thus you get t2 to be d by v1 plus v2. You got your time 2, you got your time 1. Time 1 is distance by velocity, d by 2 into v naught. You know total time period is t1 plus t2, which is d by 2 v naught plus d by v1 plus v2. And you know they are asking for speed, average speed. So average speed is total distance by total time taken. D is the total distance by total time taken is 2 v naught by d by v1 plus v2. As usual, from the denominator you can see take d out. 1 by 2 v naught plus 1 by v1 plus v2. So thus you have to take an LCM and switch it up, and then you get your average speed 2 into v naught into v1 plus v2. So when you take an LCM in the denominator, you get v1 plus v2 plus 2 v naught. So this goes up. So 2 v naught into v1 plus v2 by v1 plus v2 plus 2 v naught will be my average speed. And this sum, whether it's average speed or average velocity, will all be the same because it's traveling along the same straight line. It's not returned back for you for the net displacement to come down. So that completes this question. So after this, there are some such as example 7. Example 7, where I gave you the position of an object is x is equal to a plus b t square with respect to time, where a is given as 8.5 and b is given as 2.5 into t square. They ask you instantaneous velocity, which will be dx by dt. You have to differentiate a constant will be 0. This will become 5 into t to the power 1. Hence, the instantaneous velocity is 5t. So they ask you for velocity at a time t is equal to 0. You know, when you substitute t as 0, you get 0 meter per second. And they ask you velocity t is equal to 2. It's 5 2s are 10 meter per second. So these are called instantaneous velocities because you're able to find the velocity at that instant of time. So then it says, what is the average velocity? So this is instantaneous velocity. Be very clear. Next is average velocity. The V average is always x2 minus x1 by t2 minus t1. This is the formula. And between a time t is equal to 2 seconds and time t is equal to 4 seconds, x2 stands for the position at time t is equal to 4 seconds, and x1 stands for a position at time t is equal to 2 seconds by 4 minus 2, t2 minus t1. So to find the position, you have a position formula here. Bring it here. X is equal to 8.5 plus 2.5 into t square, where you want to find x when t is equal to 4 and x when t is equal to 2. Just substitute t as 4, 8.5 plus 2.5 into 16 and 8.5 plus 2.5 into 4. Thus you get x2 and x1, x2 and x1. Just subtract these two answers, divide by 4 minus 2, you'll get the answer. So then therefore you'll get, what is it, 8.5 plus 2.5 into 16 minus 8.5 plus 2.5 into 4 by a 4 minus 2. So then you have to multiply this and add it with 8.5. Multiply this with add it with 8.5, or you can alternatively take out 8.5. Okay, so that's all you can do. They can't do anything. Just multiply it. 16, 25 into 16, 16, 5, so 80, 32, 40. So 40 and a 48.5 is all you get. Minus 2.5 into 4 is 10 and 18.5 by a 2. So this will become 30.0 by 2. So answer will be 15 meter per second. That will be a V average. So you should understand the difference between instantaneous velocity and average velocity very clearly. Let's go to example 8. Example 8, they have given position to be 18t plus 5t square. They ask you to calculate instantaneous velocity. It's just differentiation of this, which is 18 into dt by dt plus 5 will become 10t meter per second. That's instantaneous velocity. They ask me for instantaneous acceleration. This has to be differentiated. 18 differentiation is 0 plus 10t differentiation is 10 into dt by dt, which is just 10 meter per second square. Thus, you can get instantaneous velocity and instantaneous acceleration. As you can see, the acceleration is not dependent on time because it's constant value. That shows an acceleration time graph is a constant, whereas the velocity time graph is a linear graph. You understand all this? Now come back. What is the average velocity? Then they're asking, okay, what is the instantaneous velocity at a time t is equal to 2 seconds? Substitute t is equal to 2 here. And time t is equal to 2 here. It's what will happen is 18 plus 20. So 28 meter per second. Thus you get the velocity, instantaneous velocity. They're asking you average velocity. The average is always x2 minus x1 by t2 minus t1. Between a time t is equal to 2 seconds and time t is equal to 3 seconds. x2 stands for time t is equal to 3 seconds and x1 stands for time t is equal to 2 seconds, and take the x values 18t plus 5, 18t plus 5t square and substitute ts3 and ts2. So 18 into 3 plus 5 into 9, and this will be 18 into 2 plus 5 into 4, and substitute these in the place of x2 minus x1 by t2 minus t1 is 3 minus 2. Thus you get your answer. So you actually calculate it. You get 99 minus 56 by 3 minus 2. Please do the calculations yourself. You get 43 meter per second. That will be your average velocity. We already calculate the acceleration, instantaneous acceleration, which is a constant. So let's go to 9th question. The 9th question is the displacement of the particle is given to be 4t square minus 15t plus 25. We want instantaneous velocity, which is dx by dt, which is 8t minus 15. The question is, when time t is equal to 0, what is the velocity? So when v at time t is equal to 0 is minus 15 meter per second. So that's all. And then what will be the value of what will be the velocity at time t is equal to 0? That's what you did. When will the velocity be 0? 8t minus 15. So t is equal to 15 by 8 seconds is when the velocity is 0. Such questions can be easily answered. So let's the particle has uniform acceleration. Okay, let's do the acceleration. You want to find the acceleration. A is dv by dt. Take this and differentiate it once again. You get 8 into dt by dt, which shows that 8 meter per second square is a constant acceleration where it's not dependent on time. So let's go to 10th question. Its velocity is 2t square plus 5. Find the change in the velocity of the particle during a time interval. When t1 is equal to 2 seconds and t2 is equal to 4 seconds, what is the change in the velocity? So then therefore you can, velocity only they're asking, they're not asking you anything else. So directly you can substitute when t1 is equal to 2 and velocity when t2 is equal to 4 is 2 into 4 plus 5. This will be 2 into 16 plus 5. Thus you can get these velocities. So you'll get this to be 13 centimeter per second, depending on the unit given in the question. This will be 37 centimeter per second. So change in the velocity is just v2 minus v1, which is 37 minus 13, which is 24 centimeter per second. That's the first part of the question where I don't need to do anything. I know that what has been given itself is only the velocity, and I don't need to differentiate anything, but they've asked me average acceleration. An average acceleration is change in velocity by change in time. Change in velocity, you know, this is the change in velocity. It's 24 by change in time between these two times is just 2 seconds. So 12 centimeter per second is my average acceleration. Supposing they ask me instantaneous acceleration that involves dv by dt, in which case I have to take velocity and differentiate it with 4t, and that is 4 centimeter per second square. It's dependent on time. The acceleration time graph itself is a linear graph because it's dependent on time. So let's go to 11th question. 11th question, t is equal to root x plus 3. Normally x only will be given in terms of t, so I'll write root x is equal to 3 minus 3. Squaring both sides, this will become a whole square, t minus 3 the whole square. So t square minus 6t plus 9. Now I can differentiate and find the velocity. Is 2t minus 6. The question is, when the velocity is 0, what will be the time? So t is equal to 3 seconds. So that's the answer for this question. You can't differentiate unless you square both sides here. Okay, so let's go to 12th question. 12th question is they have given acceleration. Is 3t square plus 2t plus 2. They're asking me to find the velocity. I know I have to integrate this. But if I have to integrate this, first thing I have to write is write it as dv by dt, which is 3t square plus 2t plus 2, so that I can take the dt to the other side and then integrate. If I don't write acceleration as dv by dt, I can never integrate. And this dt is common throughout. It's integration of 1 dv. This 3 can be taken out. Integration of t square dt can be brought in. Plus 2 can be taken out from here. Integration of t into dt. Plus this 2 can be taken out. Integration of 1 into dt. Now we can integrate. And integration of 1 dv is v. Plus 3 into integration of t to the power 2 is t to the power 3 by 3. Plus t to the power 1 is t to the power 2 by 2. Plus 2 into integration of 1 dt is t. And whenever you integrate, there will be a variation between the left hand side and right hand side if you're putting as value c there, a constant c. Now they have given that the velocity is 2 when time is 0. Therefore, I found c. And now I can resubstitute back in this, thus I get velocity's formula 3t cubed by 3 plus 2t square by 2 plus 2t plus 2. Thus, I got the velocity equation is 3 cube plus t square plus 2t plus 2 meter per second or whatever. Okay, find the velocity at the end of 2 seconds. So, put 2 to the 4, 4 to the 8, 2 to the 4 plus 4 to the 8 plus 2 and add all this and get your answer, which is 18 meter per second. So, I hope you understood these questions. Next is about the equations of motion. I'll just tell you how to find the equations of motion once again. So coming back to now, what did I teach after this is the equations of motion. So what are the 3 equations of motion which you learned in 9th standard itself? Is v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as, and we have to derive this using calculus method. Calculus method means using differentiation and integration, the first method. Okay, in the first method, you know how you're going to do. You should start with, you want to get the first one, you should start with a is equal to dv by dt, cross multiply dv is equal to a into dt. Now what you do, integrate both sides. dv can be nothing but 1 dv, dt is 1 dt, integrated from u to v, and time is integrated from 0 to t. When you integrate 1 dv to be v, upper limit minus lower limit will be v minus u. When you integrate 1 dt, you'll get t minus 0, so t, so v is equal to u plus at, we got the first equation. Using calculus method, we have to get the second equation, and you have to start with velocity is equal to ds by dt. ds is equal to v into dt. If you forget to substitute the v from the first equation here, we cannot do it. V itself is u plus at into dt, where integration, the dt is common for both. So this is 1 ds. An integration of 1 ds is equal to integration of u into dt plus integration of at into dt. And from this, you're going to take out u common because u is just a coefficient, which is a constant here, and a is a coefficient, t in dt, as integration of 1 ds. Now, you know this can be integrated from 0 to t because time is a variable. This is also 0 to t, but this is from 0 to s. Integration of 1 ds is s, upper limit minus lower limit is s. Sometimes they'll give you x0 minus x1, so x1 minus x0 upper, depending on, but we are taking it as 0 to s, is equal to u into 0 to t, integration of 1 dt is t, upper limit minus lower limit is t, plus a into integration of t dt is t square by 2, upper limit minus lower limit is t square by 2 minus 0 square by 2, still is t square by 2. Thus you got the second equation of motion. The third equation of motion is v square minus u square is equal to a. It's very complicated. You take a is equal to dv by dt and multiply and divide by ds by ds and do a band-aid here and write this as velocity into dv by ds. Now cross multiplying a into ds is equal to v into dv. You can integrate both sides, including v, because this will be integrated from u to v, this will be integrated from 0 to s. So as you integrate 1 ds will become just s, upper limit minus lower limit is also s. A v dv is v square by 2 and an upper limit minus lower limit will be v square by 2 minus u square by 2 Hence v square minus u square is equal to as, and thus you got all the three equations of motion using calculus method. Play it again and again and become very clear with the calculus method. Next method is straight line motion. Supposing this is the origin, this is at a time period t. Time period t is equal to 0, the position is x naught and the velocity is u. At a time period t is equal to t, the position is x and the velocity is v. Let's calculate, let's find the first equation of motion using acceleration. An average acceleration, you know from the numerical that you did, is change in velocity v2 minus v1 by t2 minus t1, which will become v minus u by t minus 0. Therefore, acceleration is v minus u by t. Therefore, v is equal to u plus at when cross multiplying. You got the first equation. The second equation of motion will start with, you're going to write average velocity. Velocity average. Velocity average. Velocity average is change in position x2 minus x1 by t2 minus t1. Here the x1 minus x naught by t minus 0 according to the graph that we drew, and this itself is s, change in position by t. Itself is average velocity v average, but in mathematics, you know v average is u plus v by 2. You can also write it as commutative addition, so v plus u by 2 is equal to s into t, multiplying both sides with v minus u. This will become, this can be written as at, oh no, not here, sorry. You get v plus u by 2 by mathematics, then you write v as u plus at. You get 2u plus at by 2 is equal to s by t. Now take the t to the other side, 2u by 2 into t plus at square by 2 is equal to s. So thus you get ut plus half at square. So this is second equation of motion. The third equation of motion, if you start from here, take this equation and multiply both sides with v minus u. But when you do that, the advantage of doing that is you get this as v square minus u square by 2. But v minus u for the first equation is at. T and t get cancelled. V square minus u square is equal to as. This is a very, very difficult derivation for you to know. Play it again and again. Become clear as to how you're getting it from here and writing. That is your third equation of motion. This is about general method, where it's about a kinematic equation for a uniformly accelerated motion. An uniformly accelerated motion is a straight line motion, and you write it like this. Next is using graphical method. How to do this using graphical method? The three equations of motion. Do a velocity time graph. Let's consider the initial velocity is u and the particle is moved to a final velocity v in a time period of t. Just do a dotted line like this, so that you name these points as A, B, C, D, E, F. The advantage of doing this is, you know, when this is a velocity time graph, and when you know slope, when you do a slope, which is tan theta, which is opposite by adjacent, you get acceleration. A velocity time graph slope photo, you get acceleration. So the first thing is you can get tan alpha or tan A acceleration, you know, or a tan theta, which is acceleration is opposite by adjacent. What is opposite? Opposite is EC, which is B minus BE minus BC, and EC, which is the opposite side, is actually EB, the whole length EB minus BC. And you know EB itself is V, BC itself is U, because from here to here is U, this is also U. From here to here is V, this is also V. So then therefore take the slope and do, what is the slope? Slope gives you a dV by dt, which is our acceleration, which is V minus U by t. Therefore A is equal to V minus U by t, or V is equal to U plus AT. You got your first equation using graphical method. So don't forget to write what is AD. AD is equal to U is equal to BC. What is BE? BE is equal to V. What is AB? AB is time period t, which is also equal to DC. Write these statements and straight away write slope. This first equation of motion is reversed. To get the second equation of motion, it's area of the triangle plus area of the rectangle. Because area under the graph will give you velocity time graph area of you get displacement. So area under the graph, I told you another name for integration is also area under the graph. So area of the triangle plus area of the rectangle. Area of the triangle is half into base, which is t, into height, which is v minus u, plus area of the rectangle is base, which is t, into height, which is u. You can write this v minus u from the first equation as at. So half t at plus ut, so ut plus half at square. Thus you get your displacement, which is area under the graph, which is by adding area of triangle plus area of rectangle. Next is the area of a trapezium. Area of trapezium itself is half into S1 plus S2 into h. Half into S1 is the side parallel side, which is this, which is u, another parallel side, which is v. So half into u plus v into h is the time period, the gap between them, which is nothing but a time period AB. So, but you know that you can, from the first equation, you can write t as v minus u by a. So then this is your displacement. So on the top you get v square minus u square by 2a. This v square minus u square is equal to 2as, and hence you get the third equation of motion using the graphical method. So these are the three equations of motion you should be very clear about. And after that, I'll be doing various graphs and stuff. We'll become thorough with this, and then we'll proceed with the next in the next video.